Hello, this is Scott Hardman. This is my presentation for my final project. I was the only participant on this group for this project, and I wanted to build a cloud-native hyperparameter optimization platform. I really wanted to focus more on the cloud-native aspect, as there's a lot of software existing that I wasn't going to be the one to improve on for hyperparameter optimization, a common problem and bottleneck for machine learning training objectives. Um, so I wanted to learn a little bit more about Kubernetes through this project. I thought that a kind of distributed and scalable cloud computing infrastructure would be really valuable for, especially for machine learning types of jobs where there can be a lot of processing required, and the ability to kind of go hands off and let the cloud take care of it was an appealing idea. My goals were to make a very simple interface. I felt like the value of this project would be lost if it was too complicated to actually enact compared to existing methods. Um, and the reason for Cloud Native was to really emphasize that scalability. Framework agnostic was kind of a stretch goal of mine. It would be really nice to have one solution that, no matter what framework you're using for your ML development, if you were able to use one solution for your hyperparameter space exploration. And then obviously cloud native integration was essential, but a big appeal. For software components, I did utilize Kubernetes, Docker, a REST server, and also artifact stores with all in Google Cloud. Docker we'll go over the architecture actually a little more later. I'll talk about how I used each of these. Hardware components is really just, I used a virtual machine, so that has to run on some hardware, and then the Kubernetes cluster nodes. And I guess you could count the storage for like my artifact store. My interaction flow, super simple. You send requests to the REST server with a body containing whatever you want to do. Those are passed on to the Kubernetes cluster, and the pods run the optimization code, and then the results come to the REST server and back to the client. Very simple. And then for debugging, I primarily relied on smoke tests, just running and seeing what broke along the way. So to show some of the ways that I use the cloud technologies, we'll follow this process. So we'll do the REST server first. So I have a virtual machine. This is counting the pods, I guess. This is the API VM. It's pretty simple. I can show the code. No, I won't show the code. It's a REST API that has a couple of different endpoints that you can send ML hyperparameter tuning jobs to. It's really a relay to the Kubernetes cluster. I then have in my artifact store a couple of Docker images that I used to create the pods in my cluster. You can see those here. It's this one that has the actual my optimizer. All the rest of these are not really where the magic happens, but right now I just have one pod up because I was just doing some basic testing jobs. And then if I get into So this is a pretty simple test I put together, but you can see how my code base is organized, and this is all API stuff, and this is all Kubernetes stuff. And then what if I want to run, so this is the external IP address of the REST API. So if I export, there we go, then I can check the health of the system. And submit a sample job with a very simple type of model. And then I'll let it go for a little bit, and then I'll check on the status. And that's my project.